Alright, welcome back to your favorite intermediate algebra course. Good to see you guys. We're going to talk about inverse functions today. And our objectives are to find some inverses of linear functions as well as for nonlinear functions, okay? Now, an inverse relation, that simply takes your original outputs, the original inputs, okay? You notice my inputs for this original function here in blue is -2, -1, 0, 1, 2. And it maps them as the output for my inverse relation, okay? In other words, the x's and the y's flip-flop. So my original outputs, my original y values become my inputs for my inverse relation, okay? So in other words, that point -2, 4 is going to become 4, -2, okay? So that'll become over here for the inverse 4, -2. That original point -1, 2, guess what? 2, -1. 0, 0 flip-flops, still 0, 0. 1, -2 becomes -2, 1. And finally, 2, -4 becomes -4, 2. So let's put all these points on the graph and kind of take a look at how these inverse relations behave. So let's do the blue ones first. -2, 4. There's our -2, 4, -1, 2, 0, 0, 1, -2, and 2, -4 right there, okay? Now in red here, so let's go 4, -2, okay? 2, -1, 2, -1, 0, 0, -2, 1, and finally -4, 2, okay? So can you see how this original 4, -2, 4, I'm sorry, um, ran over here to 4, -2. That original -1, 2 ends up being 2, -1. You see that there? Of course, the 0, 0 stuck right there. That original 1, -2, originally 1, -2, hopped over there to -2, 1, and so on. That 2, -4 came over here to that -4, 2. Okay, so maybe you can see this, and maybe if we had some more ordered pairs, it might also be easier to see. But those are a reflection. They are a reflection about this line y equals x. Okay, they're a reflection about the line y equals x. So if you have an inverse relation, again, it's reflecting about that line y equals x. Okay, and so what you have here is, let me do a new page here. Okay, by definition, if you have an inverse function, okay, now notice I said inverse function, meaning that both f and its inverse are both functions themselves, okay? By definition, inverse functions that are test, it will satisfy the following. F of g of x, where g of x is the inverse, will spit out x, and g of f of x will equal x. So if you run their composition both ways, okay, then the composition will spit out x. Remember, they're a reflection about that line y equals x, right? So that's why their composition is going to give you x, okay? So g here, note, g is considered inverse of f. Red, f inverse, okay, and notated by f inverse of x. Okay, so here I'm considering g of x to be the same as f inverse of x. Okay, so when I say f of g of x equals x, that's the same thing as f of the inverse of x, spitting out x. Okay, so g is again the inverse of f, and f is the inverse of g. Okay. Now let's talk about how you would find an inverse, okay, if you have an equation. So let's say you have let's go with y equals 3x minus 1. Okay. Now remember, the old inputs, so the inputs for y equals 3x minus 1, in other words, your x values will become your y values, and your old y values or outputs become the inputs for your inverse relation. Okay, so the first step you want to do when you're finding an inverse is step one, um, switch x and y. So let me make the y an x and the x a y. And everything else is the same. Okay? Now step two is I want to go ahead and solve for that new y, if you will. Okay? So I'm solving, see the 3y right there, I'm solving for that y. So I go ahead and solve that. So let's add 1 both sides here. X plus 1 equals 3y. Now we're going to divide by 3 each of these, right? So y equals, 1/3 x, same thing as x over 3, plus 1/3. Let me write it this way. Okay? And now step 3 is I'm going to go ahead and name it the inverse. Okay? So if your original function, you know how this original function could also be written as f of x equals 3x minus 1. So we're going to name this new one the inverse. This is our new one, right? Okay. And let's think about this. If this original f of x is 3x minus 1, and if you plugged in, let's say you plugged in 1, 3 times 1 minus 1, you get 2, right? Well, that means on the inverse here, I circled it in green, so x, y, or x inverse, right? If I plug 2 in to this function, what's my inverse function? 1/3 x plus 1/3, right? If I plug 2 in, I got 1/3 times 2, so 2/3 plus 1/3, which is 3/3, or 1. You see how those flip-flop there? Okay. Now, I haven't verified if those are actually inverses, so let's go ahead and verify that. So I've just found the proposed inverse. Now I'm going to actually verify that Alright, so verify that those are inverses. Well, again, if they're truly inverses, that means the test is take their composition, and it should spit out x, right? F of g of x equals x, or f of the inverse equals x. But it's got to go the other way around, too. So f inverse of f of x has got to spit out x as well. Okay? So let's go ahead and do that. So let's go f of, so we're gonna punch in our inverse right here. What's our inverse? 1/3 x plus 1/3. 1/3 x plus 1/3, right? And now I'm gonna run f on that. So f of x is 3x plus 1, right? 3x minus 1, I'm sorry. Okay, and what do we plug in for the x? Gotta plug that 1/3 x plus 1/3 in, right? Go ahead and distribute that. So I got 3/3 x, or 1, plus 3/3, plus 1, and then minus 1. Minus 1 on the end, right? You got that, that's in red there. Of course, 1 minus 1 gone. So x, did it really equal x? Yeah, it did, right? We had to verify this, so check mark. So far, so good. Now let's go the other way. F inverse on the f, it should equal x. So f inverse, what is f of x? F of x is at 3x minus 1. Now I'm running 1/3 x plus 1/3. So let me take the inverse. 1/3 x, leave a big space for that x, plus 1/3. What do I plug in there? At 3x minus 1. Okay, go ahead, distribute. That's 3/3 x, or 1x. 1/3 times -1 minus 1/3. Got the plus 1/3 still. Notice those cancel. Hey, x equals x. Check mark. Yes, they are inverses. I just showed my verification there. Okay? All right, let's do one a little bit more difficult here. Let's say okay, so we got this 1/4 x squared where x is less than or equal to 2. Okay, find the inverse of the function there. Now, why in the world would they say find the inverse and then restrict the domain and say the domain's only where x is less than or equal to 0? Well, to have an inverse in the first place, you have to be 1-to-1, which means you pass the horizontal line test, okay, if you remember that. So if you were graphing this, let's say you want to take a look at this, right? You plugged in, you're like, well, let me plug in 0. 1/4 times 0 squared, 0. Let me plug in 1. 1 squared, 1. That's a fourth, right? Plug in -1, I get a fourth, and so on. Anyways, you start graphing this thing, and you're like, okay, it looks something like this, right? It's got like a vertical shrink there with that 1/4. So that 1/4 is less than 1. Okay, but now it's restricted. X can only be less than or equal to 0. Okay, only less than or equal to 0. So this right hand side, we don't have that. Okay, so it's only that part of it. Okay, it's only that part of it. Okay, now you notice this thing passes the horizontal line test, right? In other words, for every uh, for each y value that you have, there's only one x value as well. Okay, so that's what that horizontal line test is testing. So, if you were before with this thing, oops, I kind of missed. But anyways, if you're picking that, you're like, wait a minute, for a y value of whatever that y value is, I have actually two x values, don't I? Okay, so for every output, there's really only one input, okay, for this one-to-one function. Anyway, so you see that they've restricted this so I can have an inverse. So let's actually do the problem now. If you remember the steps here, first of all, let's make sure that we know f of x is y, right? It's just a nickname for y. Okay, and then our first step was let's flip-flop x and y. Switch x and y. And now we got to solve for that new y. All right, solve for that new y. So we got to get rid of that 1/4 now. So let's multiply both sides by 4/1. So we multiply both sides by that 4/1, right? And so we got 4x equals y squared. Let me change those around. Y squared equals 4x. And now we square root. So y equals plus or minus square root of 4 is 2 root x, right? So the question is, which one is it? Which one is it? Is it the positive one? Is it the positive 2 root x? Or is it the negative one? Is the question. Okay. And now the positive 2 root x, if you plug like 1 in, now 2 times the square root of 1, square root of 1 is 1, 2 times 1, 2, right? Of course, 0, 0, right? Let's plug in another nice number for x. How about 4? Square root of 4 we know. So if I plug 4 in for x, that's what I said. 4 there, square root of 4 is 2. 2 times the 2 in front there, 4. So 4, 4, right? So anyways, we got a couple points here. 1, 2, of course we had the 0, 0, 4, 4. Okay, so this is pretty. So there's our 2 root x, okay? Now if you plug in now these same points, 1, 0, 4, guess what's going to happen? It's just going to make a -2, a -4, right? This is going to be a reflection about the x-axis, right? Let me do this one in green. So it's going to end up being like this, okay? You'll have that 1, -2, 0, 0, 4, negative 4, anyways, and so on, okay? So which one of these is flip-flopping my points, right? Which one of these is flip-flopping my points? Well, if you noticed, when we had originally 1 comma 1/4, so it would spit out the other way around would be 1/4 comma 1. So why don't we check this point right here. Let's keep going until we get, you notice this point right here? That'll be kind of a giveaway, won't it? So if I have 2 instead for my x on this original 1/4 x squared, what's it spit out here? 2 squared is 4. 4 times that 1/4, 4/4. But remember, I can only be picking x values less than or equal to 0. So actually, let's pick a negative 2. That's actually the giveaway right here. Negative 2 squared is 4. 4 times that 1/4 in front, 4/4. Right? So negative 2, 1. Well, which one of these actually has the point, this point switched around? In other words, 1, negative 2. I'm like, oh, it's this one, right? That's the one, okay? That's the one, 1, negative 2. Let me do this so it's actually the one down here is the reflection of that original blue function. So which one of these do I pick? Well, it's got to be this one then, negative 2 root x. That's the one that flips those points around for me, okay? Because they restricted our domain, okay? Now, if you think about this thing, you're like, oh, that one, reflection about the y-axis, that is going to end up like right here, isn't it? This point's going to end up, about that point and so on. So you see those reflection about that y-axis there. Okay, so it's not that top one. It's actually y equals negative 2 root x, and that's your inverse. And really, right here, we should say, let me extend this a little bit. We got to rename this y equals as this is the actual inverse. The inverse is negative 2 root x. Okay, so that really took a little more thought behind that problem than simply switching x, y's and solving it. Okay, so think about that, especially if you have a nonlinear function. Okay. All right. What about if you got how about f of x equals 1/3 x cubed plus 2? If you punch that in, you're like, well, it's kind of something like that a little bit. Whoops. Best I can there. There's the original function. Okay. So is this thing past the one-to-one test? Sure. Yeah, you see that the horizontal line test tells you this is one-to-one, right? Every time if you run horizontal lines through, you only hit once, right, through that function. So you know it's one-to-one, so you know you have an inverse here. Okay, whoops. So let's go ahead and find algebraically the inverse now. So go ahead and say, well, f of x nickname for y before I switch them. Let me make that a y. Now let's switch our x and y. So this y becomes x, that x becomes a y. I gotta solve for that new y, right? So let me go ahead, I gotta get rid of that 2 first there. Okay, so 1/3 y cubed equals x minus 2. Go ahead and multiply by 3 both sides. Which means I gotta multiply everything by 3, right? Each of those terms. So y cubed equals 3x minus 6. And now you got y cubed, right? I just need y by itself. So how do you undo the cube? Well, I take it to the 1/3 power. In other words, I take the third root, right? I take the third root. See how you got 3 y to the third, to y cubed to the 1/3 there? Which means you multiply those, don't you? 3/3, y to the 1. That's why we do that. Y to the 1 equals, and let me put this in radical notation, the third root of 3x minus 6. Okay, so here is our actual inverse here, the third root of 3x minus 6. And notice that you are an odd root. See the index there is 3? You're an odd root. So you don't have 2 roots here that you have to consider and analyze which one it is, like on that last problem. Okay, so that's finding some inverse functions. So if you guys got any questions, let me know in class. Talk to you later.